Barnard 68 is a molecular cloud, also referred to as a dark absorption nebula. Well within our own galaxy and existing in the southern constellation of Ophiuchus, Barnard 68 is approximated to be in the region of 400 light-years away, and so close that not a single star can be seen between it and the Sun. Discovered by American astronomer Edward Emerson Barnard in 1919, Barnard was cataloguing a series of dark nebulae, and by the time he had published his findings in 1927, had come across 370 dark objects visible to a telescope and making micrometer measurements of planets, globular clusters, and planetary nebulae. This was done by using long-time exposure, a technique which, although still used today, is a subdiscipline in amateur astronomy for those seeking aesthetically beautiful images rather than scientific data. Barnard 68 is colder than cold, and because of its opacity, its interior temperature is estimated to be all the way down to minus 257 Celsius or minus 431 Fahrenheit. The nebula's overall mass is in the region of twice that of our Sun and measuring about half a light-year across. Despite being opaque at visible light wavelengths, use of the Very Large Telescope at the European Southern Observatory in the Atacama Desert of northern Chile, astronomers have discovered that this strange mass blocks out somewhere in the region of 3,700 stars on the opposite side. Observations obtained by the Herschel Space Observatory team were able to constrain the distribution of the dust component and its temperature even more. Having a dark cloud in the solar neighborhood greatly facilitates observation and measurement. If undisrupted by external forces, the stability of the cloud dust is a fine balance between outward pressure caused by heat or pressure of the cloud's contents and the inward gravitational forces generated by the same particles. This in turn causes the cloud to wobble or oscillate in a manner similar to a large soap bubble. And more interestingly still, Barnard 68 holds the very real potential to create and become a star. Gravity must gain the upper hand for a sustained period to cause the cloud to collapse in on itself. Reaching the right temperature and density, fusion, the reaction in which two or more atomic nuclei are combined, can take place. When this happens, the much smaller size of the star's envelope signals a new balance between greatly increased gravity and radiation pressure. For Barnard 68, gravitational collapse is inevitable, but it's going to take up to 200,000 years before we'll be able to see the end result. The cloud mass is estimated to be twice that of our Sun, with a width of about half a light-year across, or if you will, 2.9 trillion miles. For context, the equator of our lovely planet is just under a humble 25,000 miles measured around, making the measurement of half a light-year difficult to picture as a unit of length. But thanks to technology here on Earth, we can definitely get a gist of just how big this black cloud in the constellation of Ophiuchus is.